What's up, my fifth graders? So we are still reviewing and remediating and talking about force and motion this week. So last week we kind of talked about the physical, the mixtures, the solutions, all that goodness. So now we're talking about why things move, how they move, and going into that. So let's get started and jump into this little video clip talking about forces, and then we'll go into our PowerPoint.
There's a piece that goes in here that is adjustable. That's why you have this gap here.
But the piece that I have is too short.
Let me see.
It's in the drain.
Have fun and learn math at the same time with Adapted Mind. A fun.
Forces make things go up. Forces make things go down. Forces make things go back and forth. Forces make things go round and round. Forces push, push, push. Forces pull, pull, pull. Here are some things that forces make move. When you slide your chair back in place, a push is the force that makes it move. When you jump up high in the air, a push is the force that makes you move. When you come back down from a jump, a pull from gravity makes you move. Forces make things go up. Forces make things go down. Forces make things go back and forth. Forces make things go round and round. When you tug the rope in a tug of war, a pull is the force that makes it move.
Remember when I beat you all in tug of war? Okay, moving on.
When you bend down and pick up a book, a pull is the force that makes it move. When you fly a kite in the air, a push from the wind makes it move. Forces push, push, push. Forces pull, pull, pull. Forces make things move. Forces are all around. If you like this video, be sure.
Awesome. Push and pull. Oh, yeah. Okay. So I get that out because I know you guys enjoy my singing so much, and you probably miss it in the classroom. So here we go. Force and motion. So look at our standard here, SC5P. What does P stand for? What does P stand for? Properties. Yes, 13.1. Identify familiar forces that cause objects to move, such as pushes or pull, including gravity acting on falling objects. So a force is a push or a pull that can cause an object to start moving, stop moving, or change its direction. The more force that is applied to an object, the greater the change in the object's motion. An object's motion is the result of force. Forces make it possible to push, lift, press, pull, and squeeze. In nature, there are a few main kinds of forces, including the following. So we have pushes and pulls, opening a door, closing a door. We have magnetism. So this is a force that is invisible to us, right? We can't really see it, but we can feel it. Gravity, this is also an invisible force, but we know that things are pulled to the center of our earth. And friction, as we're pushing something, there's something acting back against it. So it's trying to slow it down. A push is a force that can cause something to move away from the person or object pushing it. Pushing can also take place when objects are touching. If I wanted to push, right? If I wanted to push something across the room, I can't just look at it and become Yoda and tell it to move. I literally have to touch it. I have to put my hands on that object to be able to move it. Some of y'all are saying, well, not really. I could put a rope around it. You could, but you're still touching it with something, right? I cannot just move something by a magical force. So pulling is a force that can cause something to move towards you or an object pulling it. Like pushing, pulling can also take place when objects are touching. So I have to be able to pull something. I have to be able to touch it. Best example of this is tug of war. I have to pull. Whoever has the most force will fall in that direction. When two objects are touching and one of them tries to move, friction is the force that acts in the opposite direction of the motion. This means that friction is a force that stops motion or slows it down. It can also create heat. So stop what you're doing and rub those hands, because you know that is the biggest example of friction. Rub, 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 rub. What's happening with your hands? It's creating what? Heat, right? And as it's creating that heat, you realize that your hands are rubbing against each other. As one hand tries to go forward, your other hand is rubbing backwards. That's why it's creating friction. That's why it's creating that heat. So down here at our picture, would you rather be guy A or guy B? Which one's going to be more fun for you? Absolutely A. So this is, if you guys don't remember, this is what we did with our exploration in the classroom. So on Tuesday, I want to do a small example of this. But what I want you to do right now is I kind of want you to hypothesize. I want you to look at our chart over here on the left-hand side. And we always do how many trials? Amazing. 3. Why? Exactly. Accountability, making sure that we are doing it to have the same answers over and over again. So if I were to take a marble and roll it across carpet, tile, wood, and cardboard, which one would go the furthest? So I want you to hypothesize. You're going to roll a marble across carpet, tile, cardboard, and wood. And I want you to tell me which one do you think would roll the furthest? But what if you're wrong? Who cares? Because it's your hypothesis. It's your opinion. So all I want you to do on Tuesday when we talk about this, I want you to tell me what you thought. All right. So gravity is the force of attraction that exists between any two objects that have mass. Stop and pause. Look up top. This is a 3rd grade standard. I know you all have learned about gravity before, but we're going over it again because maybe your brains might have forgot something, or maybe you will connect with something a little bit better the 3rd time around. It is the basic force of the universe. Gravity keeps the planets orbiting around the sun, and it pulls objects on Earth toward the Earth's center. Our core of our Earth is like a magnet. It is not a magnet. It is like a magnet and wants to pull everything towards the center of it. This is why objects fall down without having a force applied to it. Magnetism, this is a 4th grade standard, so you learned about this last year. Magnetism is an attractive or repulsive force between magnetic materials. So we know that it has 2 poles, it has a north and a south. Magnetism is a force that can act from a distance depending on the strength of the magnet. One big example of this is the trains that we use at Walt Disney World. In the airports, they actually use the magnets. They put 2 repulsive sides, so a north and a north, and it will actually slow down a train by slowly repulsating. It could also pull the train by putting a north and a south and pulling it closer together, acting on a distance. If you put 2 magnets together with different poles pointing towards one another, the magnets will attract and pull each other in. If you try to put 2 magnets together with the same poles, so south and south, what will happen? Exactly, they will do what? Repel or push away. On Tuesday, I want to show a video as well talking about the magnets. I know we did these in person, but we will do it together on Tuesday too. All right, guys, here we go. Suzette drops a ball and it falls to the ground. What does this illustrate about gravity? A, gravity pulls the ball towards the center of the earth. B, gravity causes friction on the ball. C, gravity pushes the ball away from Suzette's hands. Or D, gravity causes the mass of the ball to decrease as it falls. What is the best answer? Right on. It is A. Yes, you always want to see the word gravity with pulling towards the center of our earth. Number 2, Elvira pushes a plastic toy car set into motion. Which force is not acting on the car? So I want you to pretend that you're pushing something. What is not acting on the car? Pulling force from gravity. So gravity pulls things where? It is invisible. It always happens. B, pushing force from her hand. C, magnetic force from the North Pole. Or D, friction between the wheels and the surface. So which one is not acting on the car? Good. C. There are no magnets, so there is no magnetic force, especially from the North and South Pole. That is just a geographical way of calling it a North and South Pole. Last one for today. Kanoa holds 2 bar magnets as shown in the picture, which the following best describes what she will feel. So we see a north and a south pointed towards each other. So what's the word whenever we think of opposites? Attract. Awesome. So we should see the word attract somewhere in our answer. Magnetic force pulls the magnets together. Maybe. Magnetic force pushes the magnets apart. The 2 magnetic fields cancel each other out, and the magnetic fields cause the magnets to heat up. Best answer is A. Yes, it will come together. Great job. Awesome. Here we go, guys. Step 2 into our PowerPoint. We're talking about changes in motions. So just previously, we talked about pushing or pulling. We talked about magnets. We talked about forces that are almost invisible. So now let's talk about when they move and how we change the motion that they are directed in. The force is needed for motion and direction. Nothing is going to move on its own unless it is by an invisible force, such as magnetism and gravity. A force is a push or pull that can start, stop, or change the direction. All motion begins with a force. So it's not going to move on its own. Force is needed to stop an object's motion. For example, the brakes on a car. Force is also needed to change the direction. Once again, we talked about playing football, and if I am on the defending team and I don't want the offensive team to run by me, I have to hit them and push them backwards. Motion is a change in position. The position of an object that is in motion is always changing. It does not stay in the same place. The direction that an object is moving might change, or it might stay the same. So in golf and baseball, I mean, you really want to hit the ball in the same direction, but it doesn't always go in the same direction. So motion is the change in position. Direction is the path along which something is moving. Words that can be used to describe this: up, down, left, right, north, south, east, west. The way that it is moving, the direction. Motion of an object is affected by the strength. If I want something to move really far, then I will push it even harder. If it weighs more, then I have to push it a lot harder. The harder an object is pushed, the further and faster it will move. But if I put the same force on each object that had the same masses, then what will happen? They'll go the same distance, right? But if I were to push a basketball that is 500 grams and push a beach ball that is 110 grams with the same force, which one will go further? Right, the one that weighs less, right? So depending on how much an object has in its mass, depending on how much force I apply to it, depends on how much motion will be caused on that object. So we've talked about balance forces. The same strength acting on an object, balance forces result in no change whatsoever. So if I'm pushing up against something and nothing is moving, that is a balanced force. I have the same amount of force pushing on one side as I do on the other side, meaning that nothing is going to happen. Balanced force equals no motion. Balanced force equals no motion. So what would cause motion? Unbalanced forces, meaning that I have something bigger on the other side pushing on something smaller on the other side, meaning that something is going to move, something is going to happen. Let me go back here real quick. Balanced forces do not cause a change in the motion of an object. Notice I have the same person on each side of that box trying to push that box. They're pushing with the same strength, the same body weight. Nothing's going to happen to that box. It's going to be in the same place. I need to have a bigger force or a bigger person on one side in order to move it. So here we go. Or no one. When you push on a box, the box will move because your force is greater than any other force acting on the box, including friction. So once again, we did this with the marbles and we clicked it. We flicked it to see what would go the furthest. If I applied a light force, a medium force, and then a large force onto the marble, which one would go further? So my control variables is I'm using a marble every single time. And then I click it lightly, and then I click it mediumly, and then I click it with a lot of force. Which marble will go the furthest? Just hypothesize. Just tell me what you think. Here we go, guys. The jet engines of a moving plane exert a force to make the plane travel forward at a constant speed. So which of these changes to the jet is likely to happen if the engines exert a greater force? So I'm going at the same pace the entire time. All of a sudden, I need to exert more force. So what is going to happen? Am I going to increase in weight? Am I going to have balance of forces? Am I going to decrease in braking distance? Or am I going to increase in speed? What's going to happen to my plane if I put more force onto the pedal, more force into the jet? Good. Yes, my jet's going to go faster. It's going to increase in speed. D, just like if I were driving a car and I put my foot all the way down on the gas, I'm going to go faster and increase in my speed as well. This car is moving in a straight line at a constant speed. Which of the motions described below does not require an unbalanced force? Does not require an unbalanced force. So unbalanced, talking about one thing is more powerful and that you're going to see something move. A, turning a corner. B, increasing in speed. C, going up a steep hill. Or D, continuing at the same speed. So unbalanced force means that something is going to change. So which one does not require a change? Good. A, turning a corner. Yeah, that's really just moving my wheel. All the other ones increasing in speed, I have to put more power onto the gas pedal. Going up a steep hill, it's going to take more force to get me up that steep hill. And continuing at the same speed, I'm still applying force to the pedal. Turning the corner, actually, guys, now that I look at this, and I hope you did say D. You all know I'm human, so it's okay. Continuing at the same speed, that means I'm putting a balanced force, meaning that nothing is going to change. Turning a corner, I'm going to have to use more power to actually turn the steering wheel. So going back and running it all through my head, I would actually change my answer to D, continuing at the same speed. So I'm going to tell the district they were wrong, just in case y'all were wondering. I hope you were smarter than the district, because we've caught that before. Last one. Ms. Takahashi comes to an intersection and the light is green. She turns right without increasing or decreasing her speed. Which of these statements is true? Which of these statements is true? So let's look at A. The forces on the car are balanced because its speed does not change. B, the forces on the car are balanced because its mass does not change. C, the forces on the car are unbalanced because the amount of friction increases. Or D, the forces on the car are unbalanced because the direction of motion changes. Guess what? We're going to talk about this live on Wednesday. So make sure you have the answer for me for exit ticket 3. I will be able to tell if you watched the PowerPoint or not. So let's keep that as a talking point. So write that down right now because I know you have a piece of paper and we will talk about it on Wednesday. Guys, you've been awesome. You have a couple of different hypotheses to give me once you watch this PowerPoint. This was a huge PowerPoint, guys, so I hope you were able to stick around and watch the whole thing. If not, splitting it up and making sure that you're able to watch all of it by Wednesday because we have a lot of talking points to talk about. For Friday, I wanted to talk about our picture for our model. I already posted up our force and motion to OneNote, so go ahead and answer those 3 questions. Kept it nice and simple because our PowerPoint is longer this week. For Friday, I want you to draw 1 example of an unbalanced force and 1 example of a balanced force. If I type into Google, I promise you will find many examples. Guys, I will see you Wednesday. This has been wonderful. I can't wait to see you on Wednesday. And ta-ta for now. Bye, guys.